So is this visible to you?
Yes, sir.
Okay,
Yes,
good.
sir.
So I think 2-3 classes has gone. So can you tell me the definition of surveying? The classical definition. What do you think about it? If somebody asks you what is the definition of surveying, feel free to tell. Please speak. Hello, are you there?
Yes, sir.
तो बोलो यार, क्या प्रॉब्लम है?
Sir, I had some internet issues. What did you ask?
Hmm? If you will not say anything, how can I go in the next slide? It is not like that, no? Please speak.
Sir, surveying is the science of making measurements of the earth, especially the surface of the earth.
Especially surface of the earth. Cannot do beneath the surface, below the
We
surface?
can do, but in general, it is for the surface.
We can do, okay, because our in the you're the mining engineering, you will take the degree. So especially our focus will be later on, will be on the beneath the surface. Okay, you're right, upper the surface, but we can also do beneath the surface. Because especially when we do the underground mining and excavation production, so we want survey there, okay? Suppose, for example, how many ton of coal you are getting out, how you know it, okay? So some calculation is there. So we should do the survey there, the production calculation for per day, per shift. Anything else? Please, one or two students to tell. You please speak. Don't be afraid, okay? Nothing will happen. Please speak.
Sir, here we will take various data and then we will make a map or a plan of that section of land or below the land. So that happens in surveying.
Good, very good, very good. What's your name?
Sir, Saurabh Raj.
Okay. So if you see, I think you almost cover both of you. Okay, good, excellent. So surveying is the art of determining the relative position of the points. Okay, on above or beneath the surface of the earth by means of direct or indirect measurement of distance, direction, and elevation. So if you see this definition, so there is a lot of sense is there. Relative position. Why I am using this word? Relative positions. Because if I say someone has the height of 5 feet and other has the height of 6 feet, so there is a relative, okay? Because I know which height is more and which height is less. So there is a relative position of the points. We should know, okay? So I think you getting the point of relative position of the points. We are not telling this point is if I say this, suppose make me understand you. If I say, sorry, 1 minute. Ooh. If I say this is 0, 0, okay? Are you able to see the screen?
Yes, sir.
So if I say this point A, so how can I say if I say this is 3 and 4? When I show it is my 0, 0 origin. Okay, so based on that, it is relatively I can able to establish A and any point in Cartesian system. So that's why it is relative positions. Later on we will see. Okay, in survey there is a need of a reference point. Otherwise it is very difficult. So I can say the relative position if I able to establish at A. So in respect to 0, 0 is the relative position of points above or beneath the surface of earth by means of direct or indirect. What we will do sometimes we will want to measure the distance. So simply I can use the tape, available instrument. I can measure it. What could be the indirect measurement? What should be the indirect measurement? Can you tell me? Indirect measurement? Anyone? Yes or no? आप लोग बोलते क्यों नहीं है? हाँ बोलिए.
We measure the distance of A from some fixed point, and from that particular point we will measure the distance of B.
So that is indirect or direct?
I think this is indirect.
You simply differentiate. Direct matlab I'm using some instruments. Okay, I'm getting physically going there and I'm using. Indirect means by using the different instruments and I'm getting our desired result. Suppose I want to making the measure the height. Okay, so what you can do? Directly you can use the theodolite or any instrument, you can measure the edge. Okay, how can you measure now indirectly? There's a number of ways. Okay, by some calculation, by analytically you can measure the height. Okay, we will discuss. Okay, that will come in the calculations later on. So our aim to measure the distance, directions and elevations. Okay, so these three terms we have to measure in the survey. It's very important to understand. Okay, so the literal meaning of the surveying is the data collection, as you have mentioned very clearly, or information collection. We all do it in any field, whatever. Okay, survey meaning is data collection or information collection. So basically, if in one word we want to say that the surveying is basically the measurement of geo information. What are the information available on the earth? Okay, we have to measure it. Okay, so this is the all definitions. Okay, I think this is up to all these things now. Okay, so the most important things come in the mind. Why we are concerned with the surveying? Why you are so much concerned with surveying of this subject? What do you learn? Can you tell me? Can you forecast it? Why we are concerned? If I will not do survey, what will happen? So why should we concerned with this survey? Anyone?
Sir, we have to construct various things in mining or civil, so we need to know what is the surrounding of that area so that we can plan properly.
Yes, very good. So I will give some one or two examples why you should be concerned in that direction, as you said. Keep in mind, survey is very easy. You should be a little bit focused in the class. Okay, some of the calculation you have to do, so you will be through. There is a very great scoring subjects if you concentrate on this. Okay, so now we are concerned, as you said, for engineering projects. You have to do the survey. For geographical mapping, a map of natural physical land features. For mapping and engineering projects. Okay, we have to do this survey. Now, if you see, for example, construction of a building. Suppose I'm giving you an example. I want to make a building. Okay, suppose you are planning to make a building at your nearby house. Okay, so what you will do? What is the first step should be there? Can you tell me? What is the first step for construction of a building?
Collection of data at the site where we construct the building.
What data?
Like means we have to do the survey.
Your main objective is to make a building. So what data you want there?
Knowing the
So
area
area of land
around
it will
which we are
cover.
going to construct.
Yeah, and
Condition of the land that it can hold that building or not.
okay. So the first step is coming there. We should do the site collection. Okay, where you will do? First you should know. Okay, suppose you want to make a home. So first you should, okay, I will make the home here. Okay, here and there. You have to fix there. Okay, now you fix there. Then what should be the next step? Next step should be the knowledge of topography. Why it is necessary? Why it is necessary?
So I'd like to know the routes by which various things can be bought or.
No, that is there. You are talking about the transport.
Yes, sir. Yes, sir.
No, no, no. First you concentrate on the building. After that we will make the way to go. First I want to make a home there. Okay. So I have selected the land. Okay. मैं यहाँ पे एक मेरा घर बनाऊंगा. Okay. Now I should know the knowledge of topography. Why? Why we need it? Why we need it? You know the meaning of topography? Then you are able to tell me. Please speak.
Knowledge of topography basically like whatever that area is, where it is elevated, where it is having a like.
Yeah. So if you are making the home, so you should know the area is the downside or upside, if there is a hill, if there is a pond, if there is a something is there. So you should know that topography. Okay. Give me 1 minute. You just think about more. So what will come in topography? Can you repeat what I said?
So the pond.
Sir, position of house.
Position of house.
The
Topography
level of
means.
This is, sir, whether it is on a hill or on a means plain surface and all,
Yeah,
and
yeah.
surrounded by
So
any.
yeah, so our earth is where you want to make the home. It is plain or it is undulating. Okay, what is the topography is there? Okay, sometimes if you see, if you say our nearby, na, this is very downside, you have to feel it. You should know that one. Okay, after that, what we do? So what we do before? How can I know that? I should have a map for that. Okay, in map I can see where is the hill, where is the that side of structure. Okay, so by map I can see, and otherwise I have to visit the site, then I should know. If there is a map I can see in the office. Okay, okay, in is this land, what is happening there? Okay, what is the structure are there, topography is there. Now third step will be planning, building on a map. So suppose you're in the office, you don't want to go there. Okay, you are the engineer, we have to first do the planning at the office where you are there. So after doing the site selection, knowledge of topography by the map, okay, then we will planning building on a map. So what will happen there? In planning, we take care of the following things. We should not damage the existing landscape. We should not damage the natural things there. We should not obstruct the existing channel network. We should not destroy the forest, which is very precious. We don't want to plan in such a way so that our requirements are met. We want to plan in such a way so that our requirements are met as well as the natural landscape is kept as it was. What does mean? What is it we are getting by this paragraph? Planning, building on a map. What are you getting? B. बोलिए.
Sir, environmental protection.
Suppose, let me add something, okay? You just try to think, okay? Suppose you are making a home there, if there is a river is there, okay? So what you will change? You will change the flow of that river. Some nalas is there, okay? The natural forest is there. So we should don't destroy them, okay? That's why it is written there. We should not. What is there? What is written there? We should not damage the existing landscape, the natural landscape. Okay. So we plan in such a way that our requirement is met with the not damage to the existing landscape. Are you getting this point?
Yes.
Yes.
Yes, sir.
So that's why the planning is there. Otherwise, there is no need. Okay. Anybody can go and make the And what will happen if you don't do this planning? The third point, it will not consider. If you're making the building, if you're not considering this planning building on a map, then what will happen? Can you forecast it? What can be happen?
Sir, it is against sustainable development.
Yeah, that is there. But before that, what will happen to home?
We will not be able to construct it.
No, suppose if there is a river, okay, and you are not you are planning to make a building, and you're not know there is a river, okay. So sometime what will be? You will face a flood there. Okay, you see in India, in the flood time, what is happening? In low-lying area, they all are affected with the flood. You know, I think it is a common problem. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Because they
Yes.
are living in the low-lying area, there is no home for that. Okay, there is a different issue. So what is there? Hello.
Flood generally occurs in rainfall.
Yeah. So network is okay, na? My network sometimes breaks. Is it okay?
Yes, sir. It's fine.
Yes, sir, it's fine.
Yeah. Now after that, after doing planning all in the office, okay, where to I will make, where is the my landscape, okay, everything I am knowing that, then I will go physically to the site, transfer building on site. So you see, okay, before site selection, knowledge of topography, planning, after that we should transfer building on a site. It is nothing happened overnight. Okay, I will go there and I will make a building. I will start constructing there. Any structure. No, it will never happen. So there is something is there. Okay. Now, so can you tell me in above example where we do require the surveying? Where is the role of surveying?
The site selection.
Site selection. Okay. And
Sir, planning.
So the knowledge of topography, and
yes, that is more.
Planning building on map.
Planning building on a map can be, then architecture can do it. Okay. I'm asking where we require only surveying. If you're doing the project, there's a number of discipline do work there. Okay. So the specific survey will be there. Where will be there?
sir, in the knowledge of topography, sir. So as
Yeah. Little bit
after
it will
knowing
be
only,
there
we'll be able to
in
plot
the,
a map.
yeah, site selection. But the second point, the knowledge of topography, that is a concern of surveying. Okay. If survey is not done correctly, so what will happen? Your map will be wrong. Am I right? If your map is wrong, then what will happen? The somebody is planning on the map, he don't know what is there. Okay, so he will do the wrong design. Because when you're making the plan, I'm getting the wrong thing in the map. That is the more concerning with the survey person, then it will be the problematic. I think you got the point where we require the survey. Is it okay?
Yes, sir.
Yeah.
Yes, sir.
Yes, huh. Any questions so far? Please ask. If don't have question, please say no. Yeah. बोलिए.
No question, sir.
Okay. Now another example. I think this is the all these things. And this is a very good example. You know Eurotunnel? नाम सुना आपने? Yes or no?
Yes, sir.
So this is tunnel between Britain and France. It starts from the Folkestone to goes into the Calais. Okay, it is very interesting civil engineering structure because the entire tunnel is in the underground, below the water. If you see the structure, okay, the entire tunnel, if you see very carefully, the entire tunnel is, if you see the tunnel, this is the sea level. Okay, entire tunnel is below the sea. Okay, there is 3 tunnels. One is for going, another for coming, and third is service tunnel. Something happen for maintenance. Third is a service tunnel. So can you tell me why it is? How we able to make it? Okay, can you tell me where is the survey is there? If there is any requirement for serving, that person is there. It is required. Yes or no?
Yes, sir, it's required.
Yes, sir.
Why?
Sir, we should know where we will go inside the water and what is the rock classification there.
No, there is no rock, no, only water. This is written there, no? It is under the water.
Sir, the topography you should know.
Topography on the land, on the
No, below the sea.
Below the sea. And anything else?
Sir, the measurement of the distance between the two.
This is from France and Britain. Is shown in the map. This distance you're talking?
With the help of survey, we can find how much will be the exact length of the tunnel required.
Okay, that is fine. Before that, you are missing one thing. Okay, just think. I'm giving you 1 minute. It's very interesting. Just think, where is the survey is there?
The depth of the ocean, sir.
Yes. What are you telling?
The depth of the ocean.
Datum the ocean. Okay, what is there? Please repeat. I'm not able to.
From the mean
of the ocean.
depth of the ocean, the tunnel.
Depth of the tunnel. Okay. Anything else? 1 minute. Yeah, tell me. One more student should tell me.
Sir, speed of water in this region.
That is surveying work. Surveyor want to know. If you're the surveying person, what should be your interest there? Speed of water, I think the other engineering discipline can do it. Because
Sir, the directions.
directions. Very good. Directions. Okay, you are very close. Directions. Because what our definition includes in the first slide? Distance, direction, and elevations. So why directions? Okay, you will read this one. Okay, what is written there? Okay, the engineers started digging from France side as well as from the UK side. Okay, simultaneously now the job was that while they're digging from both the ends, they should meet one point. Okay, they are coming from this side also and they are coming from this side also, because we have had to make it fast now. Okay, from both the ends they should meet at one point with very accurate measurement. There should not be any deviation in these two center lines. Are you agree with it?
Yes, sir.
Okay, otherwise what will happen? If otherwise it is coming like that, yeah, and it will go like that. They will never meet. So it is what is the disaster for any project. So we have to maintain the center line. Okay, what is the direction of moving this one and what is the direction of moving this one? They exactly match. Okay, then it is the called perfect. So it can be how it is possible. How did it happen? So I will say the surveying, the job of the surveyor there was to ensure the tunneling is proceeding in the right direction. This is the main job of the surveyor. Okay, somebody had said the direction now. So this is the exact meaning for the direction. Okay, how it is tunnel is proceeding in the right direction. Okay, of course there will be technology. I'm not denying it. Only a surveyor will do all the things. No. Okay, if you are doing any project, the all branches are there. Okay, So of course there's a technology because we are making with the under the water. Okay, so this is the classical example of where we want the survey.
Yes,
Okay.
sir.
Yes.
Sir, how did the surveyor ensure that the tunnel is proceeding in the right direction?
Yeah. Okay. What happens when we have some instrument? Okay, that we will tell us where is the true north. Okay, if the surveyor is there, it will tell us the what is the true north. Okay, what is the direction of the true north? Okay, if this direction, I should know the true north. Okay, now what will happen? Suppose from the true north direction at the 30°. Okay, at from the true north, you are going with the 30°. You are getting the from this side, and from this side you are also going with the suppose 45°. Okay, so throughout this tunneling, you have to maintain that angle. Okay, otherwise what is, suppose you are going in that direction, you change 45 to 47. What will happen? You start deviating. It will never meet. Are you getting my point? The direction of the tunnel proceeding you should know. You have to maintain that. Are you getting? You're following me?
Yes, sir.
Yes, sir.
Okay, there is some instrument. Okay, you cannot do. Okay, I will go and I will do something. There is some instruments. The theodolite, the very sensitive theodolites. Okay, 1 second. Okay, so this is called gyro theodolites. Okay, the other costly equipment is there. Okay, it is possible. Okay, it is possible. You can maintain that one. Okay. Okay, this is the okay. I can tell this is a very big example. Suppose your tunnel, railway tunnel. I think you have seen. Okay, going through the rail. How they're making it. Okay. So there is some center line should be there. Okay, you have to maintain that center of that tunnel. So surveying is required. So you got the gist. Why we are concerned with the surveying?
Yes, sir.
Yeah. So what can be the other example? I think after taking 2 examples, can you tell me n number of examples? You tell me. What comes in your mind? Please tell me. What can be the other examples?
The construction of bridge.
Yeah, very good. Next, anyone else? Hmm? What can be other?
Construction of roads.
Huh?
Construction of roads.
Okay. Okay. Anyone else? Okay, I'm giving some hint. How the military use the survey? Can you tell me? Just think about it. In the military, air force, whatever the force you imagine, the survey is required there or not?
Yes, sir.
Why?
Sir, like to find the easiest paths in mountain areas and
Okay.
Sir, they choose checkpoints such that it covers large area, like in high regions.
Large area for what?
Cover range so that it can maintain see it.
I'm not getting maintain what?
Like in Jammu Kashmir, they will, like in hilly areas, they will make their checkpost in
Okay.
high regions so they can see in a large area what their activities are.
But for that they want some instrument, no?
Yes, sir.
Yeah. Survey. It's no. Listen, when you, I'm asking the example. Now you just keep how to what to measure, what is the direction, what is the height. Survey means the collection of the information, some data. So how can you use it? So my question is in military. Okay, what distance, what direction you want to measure there?
For making underground bunkers.
Yeah, underground bunkers. Good. Yeah, and anything else? Hmm? Please think. Hmm?
Or to spread landmines in a region.
Landmines in the regions. Okay, okay. I have to.
The artillery firing.
Yes. What's your name?
Sir, Saurabh Chaudhary.
Saurabh Chaudhary. So how can you use survey there? Can you tell me?
So like the bombs should be fired at the exact direction at exact distance.
Yes. This is a perfect example. Okay. You should give the location, some latitude departure. Okay. It should fire there. Okay. If you miss that, it will then what is it can be an issue. It should not miss. So some coordinates you should give there. It will go there and blast. It is not possible without if you don't know the survey. Technology is there, okay. I'm not denying about it. Okay, so some basics of survey is also there. Okay, so if you see the other example, the deformation of dam. Okay, some dam is there, it's deforming. How you should know? You have to measure it by any instrument. Okay, bridge planning, as you said, you have to plan a bridge. You should use the survey. Tilt of tower, like Taj Mahal, Qutub Minar. Somebody is saying na in the research is tilting. Have you heard about it?
Yes, sir.
So how we know it
Yes.
is tilting? Okay, some techniques are there. Some surveying is there. Okay, kitna degree pe what is the degree of deflection? How we know it? As you say, artillery bombing. Okay, suppose you have from X to Y, you have to put a firing. So the position of this point, make it A, make it B. So X, Y, Z of you're putting from here. So the coordinates of this you should know. How you know these coordinates? Okay, so this is all about like missile. You want to missile, so we'll give some target points. You should know it. So it can be any other examples. I think there's a number of things you can say where we use the survey. But it's not like this. We are not confined with these examples. There's a number of way we can say the survey is useful. Okay, it is very useful. Being an engineer, whatever the engineer, okay, they should know about some basics of the survey. Okay, it is required in your general life. It will be help you in lot of way. Okay, now so if I combine all the things whatever you discussed in last 30 minutes, if I want to say in the essence, okay, what can I say? In other words, surveying is art and science of obtaining quantified and qualified measurements of geoinformation, the interpretation of these measurement and a meaningful presentation of a result. Okay, I'm again reading some of the words. It's very compact definition. Okay, surveying is art and science of obtaining quantified and qualified measurement. What you understand by this sentence? Anyone can help me out? Hmm?
The
Anyone?
quantified means data, like the distance and those things.
Quantity. Quantified means I want quantity. What is the distance? What is the direction? Quantity. And what does the measure qualified?
Sir, precise.
Yeah, qualified means quality data I want. I don't want vague data. Otherwise, what will happen? You want to hit the target with the missile, it will go somewhere else. So art, science, you can say technique to obtaining quantified and qualified measurement of geoinformation, then the interpretation of these measurement, you will use this data for our objective. If you know the topography of any area, I can use it with the n numbers, as we see in the previous examples. The interpretation of these measurement and a meaningful presentation of a result, so that we can use for any projects. Okay, like there is an body of the government of India, Survey of India. What is, Survey of India does, what will they do? Survey of India. नाम सुना आपने?
Yes, sir.
क्या करता है ये? This organization, this body?
Surveys in the land.
It make the map. Okay. Okay. If you want, suppose your home is at Bihar at somewhere. Okay. You want the map of that area. Okay. You want to do some project, big projects. Okay. So you have to take the map from there. They will charge you something. Okay. Whatever the map you can take from there. Okay. You can see the topography is there. So there is a work to survey all around the India. Another body is Geological Survey of India. Geological Survey of India. What they do? GSI. What they do? नाम सुना आपने?
Yes, sir.
So the geological information, okay. What can be the geological information? Where is the mineral? Okay. Okay, where is the coal? Where is the other mines? Okay. So it can help us because Survey of India will give the all map. Okay. The geological survey will give the geological things in the map. Okay. So these are the body where we can use it to take the map from that side. So you're getting something? Can I go to the next slide?
Yes,
Yeah.
Yes, sir.
Okay. Any question you can interrupt me, okay? I'm going in the next slide. Okay, now, as we know, if I want to do the survey, okay, I want some reference system. Otherwise, if I don't know reference system, then how I know? Okay, as I discussed, okay, the simplest example. If I know this A at 3, 4, I know where is 0, 0. It is not possible to locate A, any point. I want the reference. So in survey there is very essential, where is your reference point? In what point of reference you are measuring the things?
किसके कॉल आ रहे थे?
Okay. So we need a reference system for fixing relative position of the points. Are you agree with it?
Yes, sir.
Yes.
Now, for example, I think you have all traveled by the train. आपने देखा है ऐसा बोर्ड कभी? ये क्या लिखा है यहाँ पे?
Yes, sir.
What is written there? The mean sea level, समुद्र तल से ऊंचाई. ऐसा पढ़ा है आपने कभी ये?
Yes, sir.
तो ये
Yes,
what
sir.
is this? Can you tell me? What is this?
Height from sea level.
Means? What is the meaning of that? 214.42. कुछ मीनिंग होना चाहिए ना? It says something.
The elevation of ground from the sea level reference.
Elevation of which ground?
That's the place of Gurgaon.
Okay, the railway station of the Gurgaon, okay, has the elevation height 214.42 meter from mean sea level. Where is mean sea level now?
I don't know. I think it's a reference.
Yeah. So something what happens? We have assumed there is a datum. Something we assumed 0. Okay. Okay. Somewhere it is mean sea level, and this is our 214.42 meter. So then it is easy to say me this is the height of this Gurgaon railway station. Okay. Otherwise, how can I measure it? The simple things. So what is mean sea level? It is described at tidal datum, that is arithmetic mean of hourly water elevation observed over the specific 19-year cycle. Okay. Mean sea level means is the datum level of your ocean. Okay. So that is we have considered zero. Okay. Something should be there is a reference. Otherwise possible nahi hoga. Okay. You got this point?
Yes.
I should go to the next slide. Any questions so far?
Sir, how can we measure it?
Measure it. Mean sea level. What do you want to measure?
Yes, sir, sea level.
Sea level is written there, no? Specific 19-year cycle. We should do the hourly tidal datum. Okay. At the ocean level, we should measure this measurement. Tidal datum. Okay. Then we say this is the mean sea level. You know why tidal datum?
No,
Yes
sir.
or no?
No,
There
sir.
is. Huh?
No, sir, I don't know.
Who knows? Anybody can tell me? Be quick. Any idea to anyone? बोलिए.
No idea, sir.
किसी को कुछ आइडिया नहीं है? अरे हम्म. 1 minute. What is the strength of the
Maybe
class? 58. Nobody knows? We have to measure the what is the height of your what will say the ocean level. Okay, you know the height of the ocean level can be increase or decrease as the time pass.
Yes, sir.
Okay, so you have to take the mean. It is written there. Okay, what is written there? If you see there, what is written there? It is described as a tidal datum, that is arithmetic mean of hourly elevation observed over the specific 19-year cycle. Okay, then we have to take the measurement, then we say this is our mean sea level. It will not change. 19-year cycle is so long. Okay, do you think it will change? Hmm? आप कम बोलते हैं क्या आप सब लोग, वरना बोलना नहीं चाहते हैं? अभिनील, अभिनील कुमार, I think he's not there.
So it might change by minute, but I think that will not matter.
Yeah. So please speak now. You speak. Why other people are not speaking? Okay. Let me handle some of the students. Amlipur is there.
Yes, sir.
Anuradha, Aniruddha. Okay. Aniruddha Panda.
Yes, sir.
You should speak some of the students. Why you are not? Why you are keeping mum every time? कुछ प्रॉब्लम है क्या, या मन नहीं करता है बोलने का? You should. Okay. So this is now. So somebody is asking how we measure it, na? Who is asking?
Sir, Anuj.
Yeah. So how we'll measure it? Okay, we can measure it, na? We have some instruments. We can measure it. Okay. Any
Yes, sir.
questions? Can I go next slide?
Yes, sir.
Yeah. For more detail, you should do some, okay, make it Google, okay. It is not like that, okay, everything will be covered in the class. If you know the good information, you can also share with me. Okay, so this is the technique to use for the tidal datum to measure the mean sea level. Okay, it's up to you. Okay. Okay. Now I think you know about this, the classification of survey. Have you read about it? It is covered or not?
Yes, sir.
So tell me, what is the classification?
Sir, plane survey and geodetic survey. Geodetic survey takes into the fact that Earth is curved. It uses that, while plane survey uses the takes that Earth is relatively flat for civil engineering or mining purposes.
Yeah,
And
for the
it is done for a 200 kilometer square area, less than that.
200
kilometer square.
kilometer square. Good. So for the small measurement, we can consider the Earth is a plane. Okay, for the long measurement, we cannot. If you see this picture, okay, see it very carefully. If I'm interested to measure the A and B here, oh sorry. So I can say the Earth is flat at this point. But if I want to measure this point C and D, then the Earth, this curvature, the curvature of Earth will come in count. Okay, so these are small things we should know. The projections to a plane surface. The project, if I project it, then it will be C or D, but on the Earth surface, it is a capital CD. I think you understand these things. So for the geodetic survey, we should consider the curvature, this curvature of the Earth. Otherwise, there is no need. Okay. So this is the one classification of survey. What can be this is the primary classification. If I go, then there is some secondary classification also there. Based on instrument, I can classify the survey. If you're using the chain, it can be chain survey, compass survey. If you're using the photography, okay, then it can be photographic survey. Based on method, I can classify. Triangulation survey, after using the making the triangle and doing the survey, the triangulation survey, traverse survey, okay. We'll all discuss all these things, okay. Based on objects, geological survey. If I'm very much interested, okay, what is the geology of that area? Then I will name it the geological survey, like GSI is doing that. Mine survey. If I'm doing for the mining, then it will come the mine survey. Archaeological survey. You know what is archaeological survey? Have you heard about it?
Sir, by that ancient things they are.
Yeah. Okay, that is also covered. This is one type of survey. How to know? Okay, this is also a survey. Okay, if you get something, then what is the beginning of that? What is the year of that? Comes in also survey. So different stream, different survey will be there based on nature of field, land surveying, marine surveying. Okay, astronomical surveying. Have you heard about astronomical surveying? Anyone?
Sir, in
This,
space.
yeah, by seeing the stars, okay, we can do the measurements. Okay, this is astronomical survey. This is the different type of survey. Okay, the position of the stars will help us to know the some measurements. So the different way you can classify the survey. Okay, the subject is very different branch. It's very okay. If I'm geological person, I will do the geological survey. If you're doing in the mining, we'll do the mine survey. Okay, but the top of that, the basics remain the same. So in this course, we'll show you how to measure this direction, distance, elevations. Okay, this is our major concern for this subject. What instrument you will use and what is the science technique behind that. That is our concern. Okay, now tell me, if you learn this principle of surveying, can you tell me what is work from whole to part? Let me explain. Otherwise, you can help me out. Please explain. Work from whole to part. You have covered it, na?
Sir, we divide the whole area in small parts so that we can minimize error.
Okay, if I will not do it, then what will happen?
The error will be larger as compared to whole to part method.
Anyone can give the example. This is theory. Can you give me the classical example and make me understand? बोलिए.
So like in last class, for a rectangular region, we were dividing it in triangular parts.
Okay. Then I have used the one word, well-conditioned triangles. Okay, what was that range? I think I missed some data. What I has written? 30 degree to?
No, 60 degree.
No, it make it 120. Okay, it is 120. Because somebody asked the question, na? Okay, sir, one angle will come. Okay, so it is 120, not 60. My mistake. Okay, you have to make a well-conditioned triangle in a such a fashion. It should be 30 to 120. Okay, in this range, more or less. Okay, the purpose of this process to prevent accumulation of error. You got this concept? Work from whole to part. The area is first enclosed by main station and main survey lines. The area is divided into the number of parts forming well-conditioned triangles. The purpose of this process is to prevent accumulation of error. Otherwise, what will happen in the survey? The error will be accumulate. Okay, we cannot control. So if you want to control the error, we should come from whole to part. If something happen, it will happen in this area. Got this point? Listen, again I am making some. If some error is there, it will happen in this. It will not affect this part. It is A or B. So something is error is in this area, it will remain there. It will not go there. Are you getting my point?
Yes, sir.
Because what we are doing, we are making the all triangles in this area. Are you getting my point? Please say yes or no.
Yes, sir.
Yes.
So what will happen if something error? Because error will be there. We only minimize the error. We cannot eliminate totally. So it will not affect the nearby area. That is the main purpose. Otherwise, what will happen? The error will keep adding. So at the end, we will be nowhere. Okay. Another point. What is the principle of surveying? Please read it. What is written there?
Sir, to locate new station by at least 2 measurements.
From fixed reference point. Can you explain it?
So like for a point, if we want to know its exact location, we will use some reference of tree or a pond nearby, and then we locate that point.
Okay, but what is the meaning of new station?
Sir, the points which are making the triangle, well-conditioned triangle.
Anybody?
New station which we are measuring, like.
So for that we want at least 2 measurement. Why? एक से नहीं होगा.
So to be so only distance cannot probably tell us, like we want to be sure.
Yes. So have you seen some pictures regarding that, this second point? To locate a new station, have you some pictures of triangle? It is covered or not? Yes or no? क्या हुआ? Yes or no?
No, sir.
You haven't seen this type of pictures? It is not covered?
No, sir.
Okay. That's why I'm asking now. So suppose the P and Q are the reference points. These are the reference points on the ground, and the distance PQ is measured accurately. I know this distance PQ. Then I want to locate this R, because in survey what we do, I know PQ and I want to know for the new point that is discussed in the last slide. I want to locate this. So what I want? So R can be located by the following direct methods. How can I locate this? I should know this distance and this distance. I can locate R. Yes or no? In figure A.
Yes, sir.
Okay. In figure B, what is there? I know P and S. Okay. And if I know S and R, still I can able to locate R.
Yes, sir.
You're getting? Can I locate R if I know only two measurement, PS or it can be SQ? No problem. And if I know SR, it is perpendicular.
Yes,
Still I
sir.
can locate R.
Yes, sir.
Okay.
Yes, sir.
What is in figure C?
We know the distance QR and the angle.
You should know the distance QR and angle
Yes.
alpha.
Yes, sir.
Yes, sir.
Okay. Now what is in figure D?
Sir, the angles both alpha
You
and
should
beta.
know the angle alpha and beta. Still I can able to locate R. Okay.
Yes.
What about in E?
Sir, the angle and the other distance.
I should know the PR and I should know the angle alpha. So what you got by these five figures? What you got?
Need two measurements at least.
So if I want to locate any new station, okay, I have the different way to make it. Okay, somebody has only the measurement device with her, with him or her, still he'll able to do it. Okay, someone has the angle measuring instrument and the length, still he can able to do it. Okay, I want only length and angle, still I can locate this new station. And somebody don't have any length measuring instrument, still if he measure the angle, I can locate R. So you see what is written there? The point R can be located by any of the following direct methods. So this is, we should decide what to do, because in survey we will keep doing the new points. Okay, so how we will measure it? New points. So that's why it is written in the last slide, to locate a new station by at least two measurement. It can be linear or angular from the fixed reference point. Whatever our fixed reference point in this slide. What is the reference point?
P and Q.
First in survey we have to fix this P and Q. Then I can do anything. Otherwise it is not possible. Okay. So both the principles are okay. You got the point? Any doubt so far?
No, sir.
Okay, so now I'm going to the next slide. What happens after all the doing the survey? I want to make a map. Okay, so what we do, the 10 meter, it is what is written 1 centimeter equal to 10 meter. This is the scale. So 1 centimeter on a map represent 10 meter on the ground. Okay, we have to convert in the scale, otherwise it's not possible. Okay, so what is there? 10 meter distance on the ground. I will show by the 1 centimeter on this map. So there is a scale should be there on the map. Okay, another is called the representative fraction, RF. Okay, so what is this? The ratio of distance on map of object. Okay, divided by corresponding actual distance of object. Okay, so if I convert it 1 centimeter equal 10 centimeter, if it is ratio, it should be in the same unit. So it will be 1 upon 1000. So RF will be, what will be the RF for that map? Hmm?
0.001.
Yeah. So this definition you should remember, okay? You should know the scales, what is the representative factors, okay? So these things are required. Okay. Now, something we are going in a bigger way. As I discussed, we want reference point. So can you think there should be some reference system for the entire Earth? Is it required or not? You listen carefully to me. We are all talking about there should be the reference point to measure the points. So is it possible to make a reference system of entire Earth? What do you think about it? Hmm?
So please repeat. I was unable to hear.
What we are last slides, what we are learning. We want reference point to make a news measurement. Is it okay? ये सीखा अब तक हमने.
Yes, sir.
Okay. So if I say you want reference point, so can I make the reference system for entire Earth?
Yes, sir. There is.
Yes, sir.
Latitude and longitude.
No, that is the position. Okay, there is the position coordinate. Okay, reference system of entire Earth. Like if you are making the graph, you are fixing something is 0, 0. Okay, that is our reference. So for entire Earth, okay, for whole universe, I will say how you make this reference system. Is it possible?
No, sir.
No or yes?
Sir, we use pole star for north.
We use what we use?
Sir, pole star.
Pole star for north. Okay.
North direction.
So that is fine. But suppose, let me explain the another way. If I say you have taken the example of mean sea level. Okay. So there is a mean sea level. So can I say that mean sea level is the reference of the entire Earth? Can I say like that?
No, sir.
No, sir.
Why?
Sir, it also changes.
Not.
Suppose there is one station at Gurgaon, it is 214.42 meter in India. Now we given UK. UK will some sort of stations also be there. So what will be the reference for there? It is again mean sea level.
Sir, but for their sea it will be.
For there, what will be?
Sir, it will be measured for their sea level.
Oh, that's why I'm asking this question. Okay, then if you are okay with your sentence, then what will happen? Then the height of in India and height of in UK will be different.
Yes, sir. I think tides will be different.
No, that we are taking the average. Okay, that we are taking the average. Is it so? I think अगर ऐसा है तो then it is a how we are communicating. You think once again. Are you getting my point? If you're not getting my point, let me know what I want to ask. It's very interesting. Please involve in the discussion.
So
What I'm
then
saying. Yes.
communicating, we can fix like a standard mean sea level for entire Earth.
Yeah, standard. That I'm asking. So it should be there, no?
Yes, sir.
Yes. Otherwise, then how can we? How can our flights and all these things is happening? We cannot do the fire all in the military. Okay, because if the reference system is different for both the country, suppose India and Pakistan this is the hot topic, so then it cannot be now. It should be same for the entire earth. Is it okay? My sentence is okay or not?
Yes, sir.
How we make it? How we make it? That we will discuss. And you should know all these things. Okay, it is not about this your subject or like that. You should know. This is very good things. I will try to make you explain. Okay. If
But
you
sir,
want to
it is
make,
a reference.
yes.
But sir, mean sea level is a reference to measure height, no? Means vertical
Yeah.
height we
Vertical.
can measure. But for
Yes.
horizontal distance, what reference is for the entire Earth?
Listen. You are little bit you are confused. You are okay all the things. Suppose this is point A and this is point B. So point it should be X and Y and Z will be there. X and Y it will be in the on the 2D. If I am talking about Z it will be 3D. For this point I should
Yes.
know X, Y, Z. For B point it should be X1, Y1 and Z1. It should be
Yes,
there.
sir. Yes.
So now if I know this point and this point exactly, then I am able to measure this distance now. Otherwise, how I'm measuring the distance? If you are
Yes,
saying
sir.
this Z is I'm taking from the different reference and this Z is from different reference, then I'm not able to do something, any project work. Are you getting my point?
Yes.
Any doubt?
But sir, the mean sea level is the reference for Z coordinate. I
Yes,
understand
Z
that, but
coordinates. Z
for
coordinate.
X and Y,
X or
is
Y.
there standard?
Yeah. Listen, for horizontal measurement hardly matters. Okay, horizontal measurements, I can take the any reference. Okay, but for height, particularly for height.
Okay,
Okay,
sir,
you're
I
right.
understood.
Yeah,
Yes, sir.
particularly for height, there should be some standard. Otherwise, we cannot do. So what is the sentence is written there? What is written there?
So where?
स्लाइड पे कुछ लिखा है?
Yes, sir. So if
क्या
we
लिखा है?
want to map entire surface of Earth, then what will be the reference system of entire Earth?
एक मिनट इरेज किधर से हो रहा है यार? 1 मिनट. Erase. So that 1 minute that I have to discuss. Yeah. So the surface of the earth, actual surface of earth cannot be taken as a reference because it is an undulating nature. If I say earth surface, I've tried to make it like that. It's undulating, na? Somewhere is plain, somewhere is deep, somewhere is a mountain. It is like that. Is it okay? It's like that, na?
Yes, sir.
Okay. And I'm saying this is X, this is Y, this is Z. Okay. Now, if I want to draw a line, okay, suppose this dotted line, okay, it is passing through some points here, and okay, it's cutting through some points. And what I say for this line, if I say this line is a geode, so I want to explain the geode. Okay, an equipotential surface on which the gravitational potential is same at all points. It means the G for all the points. What I done in entire this earth surface, I want to do like that. If there is a equipotential gravitational potential should be same. Okay, there is n number of points and I connect that n number of points. That is called the geode. This is hypothetically I am telling to you. Okay, geode an equipotential surface on which the gravitational potential is same at all points everywhere. If we draw a perpendicular from a geode, it will show the direction of the gravity. Can I do hypothetically?
Yes, sir.
Okay, what I want to do, where is the G is same gravitational potential, I find that point, I connect that point. Hypothetically I want to do it. Okay, so now what will happen in the earth? There can be n number of geode, then it is possible. Am I right?
Yes, sir.
Okay, so somewhere will be there. So somewhere will be, what will happen? If I consider this geode, your y will be at the high point. If I consider this, it will be the high. And if I consider this geode, it will be the at lower side. It can be possible. Yes or no?
Yes.
Yes, sir.
So it means there's a different geode should be there. Okay, again the question comes, which geode I should consider? Because if I consider this one, then it's, if somebody is consider this geode and I'm changing, someone is changing this is to this one, again I'm in the problem. Am I right?
Yes, sir.
Again, so what I want to say, geode is a used to reference for the elevation measurement, as you said, for the Z point. Okay, so again my problem is not solved because there's n number of geodes. So what should I do? What can I do? So there's a one question comes in the mind, is any equipotential surface physically available to us? ऐसा सरफेस है जो हमारे पास ये मेरे प्रॉब्लम सॉल्व कर दे कि geode, we have defined the geode, is this type of surface is there? What is the answer? Please try to understand.
Sir, mean sea level.
Yeah, mean sea level. So what is the answer? Answer is yes. The surface of the water body in such a way that everywhere means whole universe, UK, France, India, whatever, the surface of the water is perpendicular to the direction of gravity. So this is the natural equipotential surface, or we can say natural geode. That's why we say our mean sea level is a reference point. You know the logic now?
Yes, sir.
Okay, otherwise we cannot say. So the question should arise. Okay, why we are saying mean sea level is our reference point? I can take any point. No. If you take any point, you will keep changing. So we want the equipotential surface. This is available to us. It can be a mean sea level. Why? The surface of the water body in such a way that everywhere the surface of water is perpendicular to the direction of the gravity. So for example, the mean sea level is our called geode. Okay, so these are the synonym. Okay, mean sea level or geode. Okay, so is it okay? Have you got the point? What I want to say?
Yes, sir.
Please explain it. What you understand?
So we needed a reference from which we can measure for the entire Earth. So we got the mean sea level because it is a equipotential surface as the water is perpendicular to the direction of gravity every time.
Yes, that's why we make it. Judicially we have done it. Okay. So this is keep in mind. Okay. Now some general information I will give you. If Earth is a perfect sphere, तो geode will be the perfect spherical. अगर ऐसा होता तो provided the gravity distribution of the gravity force all over the Earth is uniform. Okay, suppose Earth is like that, is a sphere. So geode will be always sphere. But what is happening? But it is not the case. You all know. If you look inside the Earth, the distribution of the mass is not uniform. Somewhere it is more, somewhere it is less. The geode is irregular because of the force of gravity isn't constant. Okay. Over the Earth's surface, gravity is stronger in some areas where dense material like iron concentrated under the Earth crust and weaker in others. See, location of the Earth measurement. So now what is happening? Again there is some problem. Mean sea level I have solved. Now what next? Can you tell me? What is the problem with this geode?
So it's not regular.
It's not regular. It means if I want to measure this point here, here and three location of the Earth. Okay, so three location will be give me the different elevations. If I consider any geode, because the gravity distribution is not the same. Okay, so what we have done? We have considered the geode. Okay, water. Okay, like Earth without topography, a level to the geode. So as we discussed in the last slide, what we have done? We have taken this water surface mean sea level as a geode. So now what has happened? We have taken the mean sea level. Okay, the water surface we have taken the as a geode. Okay, now it's very easy to us. You got my point?
Yes, sir.
Okay. Another problem, if I not do this water, if I not consider the mean sea level as a water, ocean level, I am not considering. Again, there is a problem. One problem, the gravity distribution is not the same. Other problem is what? The shape of the geode is not mathematically defined. Okay, because if you want to work on with this geode, okay, so if you want to locate the x, y, z, okay, in between point if you want to define, okay, then you want some mathematically defined equation. What I want to say, I make you understand. Okay, suppose you know this point, and this point. In between I want any point. How can I measure then? Because I don't know, because my geode is not mathematically defined. So again there is a problem. So even if our project our point into the geode, onto the geode, we don't know anything between these points. So for simplicity, we have taken this water surface. So in this case, we have to define another surface. Okay, and this surface is called the ellipsoid. So sometimes you see in the discovery or we can say now our Earth is a shape of the ellipsoid. Why we say like that? Shape of the Earth is ellipsoid. Why we say like that? Because which is mathematically defined. So what is the benefit if I define the Earth is a ellipsoid? Then what is our benefit? Can you tell me? You're not getting my point, or something is problem.
So we can like approximately know which point will lie where.
Yeah. So what is happening? So ellipsoid is a simplification. It is a simplification or approximation of geode. Let me try. Okay. This is the shape of the Earth. Okay. That is uneven. Okay. I want to measure the Z. So I say this is the now my mean sea level. I have defined it. There is a water level will be our mean sea level. Okay. Now, if I want to make the entire Earth, okay, so then what to do? Then I have to approximate my Earth is a ellipsoid. So what is the benefit of this ellipsoid now? Can you tell me?
It simplifies calculations.
Yes, be loud.
It simplifies calculations.
Yeah, now if I know the ellipsoid, if I simplified, there is the Earth. I approximate with the geode, okay, without topography. Because if I say geode is only xy na, mean sea level, okay. Now if I consider it is a ellipsoid, so now I know this equation ellipsoid. I know the entire equation of the ellipsoid. So I know if I x this point A, B and C. So everywhere I can define my points. Everywhere I can define because it is a mathematically defined this ellipsoid. So now where you use it, when you use these instruments, any instruments like total station or anything, we have to give our reference system. Okay, which ellipsoid we are able to, what is our reference system, which ellipsoid we are following. Okay, based on that ellipsoid, we are able to measure the Z heights. Okay, like if you see the best fitting global geocentric ellipsoid is the geodetic reference system. This is called GRS-80. So you have to select this one in our instrument when you are interested in the Z heights. Okay, so what is the major axis? Because ellipsoid has the major axis and minor axis. This is the dimensions. Okay, then we are able to measure these heights. Otherwise, we cannot. So this is the global geocentric ellipsoid. You can remember this GRS-80. More information you will get from the internet. Okay, no problem. So now see the dynamics. If this is the Earth surface, see this is the Earth surface. Okay, and this is the geode. I have making the geode, the blue, the ocean line, you can say. Okay, on top of that, okay, again we have done we have made the ellipsoid. This is mathematically defined to us. You got my point?
Yes, sir.
Okay, if now the calculation comes very easy to us. So see in this geode the approximate mean sea level. Then if I want to know the orthometric height, I define the distance between Earth surface and geode. Earth surface and geode. This height is called the orthometric height. Capital H. Okay. Ellipsoidal height. Small h. The height of Earth's surface above or below the ellipsoid. This Earth. So what is written there? Height of Earth's surface below, above or below the ellipsoid. Earth surface this and the ellipsoid. This distance. Okay, this distance. This is called the ellipsoidal height. Geode undulation n. Distance between ellipsoid and geode. Distance between, this is the geode, this is the ellipsoid. So this is the different way we can define. So what you have learned, can you tell me by up to so far? What you have learned? Tell me. You got something? Yeah.
Yeah, sir. We need a reference system for that. We need to consider a surface which can give us a good reference, and so that we are considering the geode and which is a ellipsoid.
Yeah. So ultimately ellipsoid is the approximation of
A geode or mean sea level.
yes. And geode is the approximation of
Points where same gravitational potential is active.
yes. So this is how we are defined. Okay. So if you see the 6 meter vertical separation between geode and ellipsoid will result in the scale error of 1 ppm parts per million. Okay, you can remember it. Okay, how the things are changing. Geode and ellipsoid. What is your geode? This is your geode and this is your ellipsoid. If 6 meter height difference, then it will give the scale error of 1 ppm. So now different countries have adopted their local ellipsoids. Okay, that give best fit in their particular situation. Okay, now if you're doing the survey in India, okay, I will use this the once the Asia is okay, is India and Pakistan, we should use this Everest. I will select this Everest 1830. Okay, Great Britain using their local where used ARI. Okay, so these are the some things. Okay, for local measurements. Okay, they can use that local ellipsoid. Now, if you know the ellipsoid, you can fit everywhere, na? So the now East India, East Indies, Australia, South Africa, they are all are ellipsoids for their local use. Okay, if there is a one coordinate f is the flattening of the ellipsoid. This is given to a minus b by a. So this is the and b is the major and minor axis. So this is all about our some basics. So what you learned today by these slides? Can you tell me? Have you
So
learned something?
So we learned the definition of surveying and then different types of surveying, some examples, and the reference point for the entire Earth, how it is defined and what will be the error in that.
Okay, so you got some interesting things. What was the new thing today to learn?
So
To know the reference system of that.
Yeah. You should know. Okay. Anyone can ask you if you're going for any interview. Okay, suppose you're going for UPSC. Okay, लेकिन अच्छा आपने माइनिंग पढ़ा है, सर्वे पढ़ा है. Anyhow they आपका CV देख के पूछ सकता है. It's a very common questions. You should know all the things. Okay, it's not for the exam clearing. Okay, it's just for your knowledge that I will say. So this is today. So introduction is no is from my side is complete. So now we will shift to the chain surveying. Okay, so I will suggest you some of the video we will show in the laboratory. Okay, so the laboratory part and the theory part will go simultaneously. I mean to say some things if I am teaching in the laboratory that will comes that will also the part of the theory. Are you getting this point?
Yes, sir.
Yes, sir.
Okay, so don't be segregate, sir. ये तो lab में पढ़ाया था, ये theory में पढ़ाया. Because surveys go like that. And the problem I can understand, you're all in the online mode, so don't worry about that. We will try as much as possible to make you understand. So next we will go to quickly on chain surveying. Okay, and very quickly we will finish chain surveying because these are all techniques. Okay, hardly anybody use the chain survey. Okay, and quickly we will go to the prismatic compass, how to take the angles, bearings, all these things. Okay, so we will go very fast. Okay, then we will go for the theodolite measurements and levelings. Okay, and at last we will go for the underground measurements. Keep in mind the basic survey is same for civil engineering and our purpose. All are same. And regarding notes, books, I think there's a number of things are available on internet. There is no problem at all for survey. Any problem, then you can tell me. If any question, let me know. Otherwise, we'll end today's class.
Sir, can you share these slides for us?
The
Yes,
slides
sir.
you want. Okay, no problem. Anything else? Anyone? Avidut. नहीं, Avidut. Avidut, you are the class representative, na?
Yes, sir.
So why only 63 are present? The all are 81, 82?
Today there is Makar Sankranti, so many people are having some puja or festival at the home.
Okay, but they can come in the class. This is the reason. So you are not celebrating that puja and.
So actually I'm in KGP, so here there is lockdown and.
Okay, no issue. Tell them, try to come in the class. Okay, and try to be involved in the class. Okay, it's very good subjects. Okay, don't take so much load about it. If you listen carefully, do some calculation, easily you will get the grade. Then what happens in this subject? I will tell you one thing. It looks very easy to students, but they will don't solve numericals and don't give the regard to the concepts. Then they will not able to score. You will feel okay, survey is very easy, we can do it, but you will not able to solve the problems in the exam because you haven't practiced it. You will keep in mind. Every time you will feel it is very easy, but you want to take the grade A or EX, then little bit you have to make the effort. And you're okay with the lower grades, then okay, fine, no problem. It's up to you all. Okay. So in next class we will go for the change surveying. Okay. So be there and okay, we'll see what can we do in the lab. Okay. Okay. Take care. Thank you.
Thank you, sir.
Okay.
Thank you, sir.
Yeah.
Thank you, sir.
Okay. Thank you.
Thank you, sir.
Yeah.
Thank you, sir.
Yeah.